Okay, we're going to take a look at this slide in this lesson. And I have an airtight container right here. Um, it has a lid that creates an airtight seal. So take a look at that. And if we were to put liquid inside of this airtight container, like this, no water can get out of the system and nothing can be added to the system as well. So nothing can go in and nothing can come out. All right, so let's take a look at the scenario. It says this container has an airtight lid. Hot water was added to it and then sealed for 24 hours. The container was then emptied. Cold water was added to it and then sealed for 24 hours. Measurements and calculations of the temperature changes of the water and the mass changes of the system are reported below. So if we look at this tabular data in this chart, we can see that when we added hot water right at the beginning, the starting temperature was 125.5 degrees. And after 24 hours, the temperature dropped 55 and 4/10 of a degree Fahrenheit. And the final temperature was 70 and 1/10 of a degree Fahrenheit. Then cold water was added. 42 degrees is the temperature of the cold water at the start. After 24 hours, the temperature increased 38.1 degrees Fahrenheit, and the final temperature of the cold water ended up being 70 and 1/10 of a degree Fahrenheit. And then over on the other side of the chart, we can look at the mass. And the starting mass of hot water, so there was 205.4 grams of water, including the container. So the mass includes the water and the container. And 24 hours later, we can see that the mass did not change. And then cold water was added. And when they massed it, it was 206.2 grams. Again, container and cold water. 24 hours later, the mass didn't change. It was the exact same at the end. So we can see that even though mass didn't change, temperature does. And we learned that when we did our cold water condensation lab, we did see an increase of mass with the cold water because the water collected on the outside of the container and that caused the mass to go up. We also did an investigation where we found that if we do not have a lid on the container, that mass can leave the system, temperature can change, and therefore so does mass. But in this investigation, in this tabular data, we can see that if it's an airtight container, that mass doesn't change after 24 hours, but temperature can change. So how can the liquid inside the container change temperature even when no matter is leaving or entering? And what might be happening? One thing that we might notice is that something can be entering the system, and that is light. So maybe we need to do an investigation on how light affects temperature inside of our system.